In this video, we're going to consider problems that involve Newton's second law, but more precisely, problems that involve the usage of F equals to ma. And I like to call this accelerating systems. And so this is a very common problem you will get in the A levels. And so let's consider a very common problem where we have a block sliding on a slope, and let's say this slope is inclined at an angle of 15 degrees. Okay, all right, let's just call it theta, right? And so we have, of course, the weight of the block, mg, okay, and we have, of course, the normal, Fn, and maybe some friction just to make things a little bit more difficult. And then we are asked to figure out the acceleration of this system, for example. And so the common approach to solving this, okay, I like to adopt my Fred approach. And so, first of all, make sure you draw a free body diagram for the object in question. And in this case, it will be the block. And so, let's draw the diagram, mg. Okay, we know we've got friction acting this way and got normal acting that way, and that's about it. Now, the next thing that is very important is then we have to ask ourselves, where is the resultant force of this system? Now, most of the time you will have to make a guess or make an intelligent guess. And in this case, usually it's pretty obvious. We expect this block to slide downwards, in which case the block should be accelerating in this direction. And so I'm just going to indicate outside of the free body diagram the direction of the resultant force, which we know from Newton's second law is ma. And now, step number 3, we are going to resolve all these forces to form some equations. Okay, E stands for equations. And always resolve your forces into an axis, which is first of all parallel to the resultant force and of course perpendicular to the resultant force. Now, you can quite clearly see that the normal and the friction are pretty well behaved, but I'll need to resolve my weight into this component and this component. So using some trigonometrical scales, okay, I know that this is theta over here, and so theta will find its way up there. And so it is case that this component here will be mg cosine theta, and this will be mg sine theta. Now we can form the equations. And so, since I know that these forces must add up to give me this resultant force, then these two guys over here must cancel out. And therefore, I can say that the normal contact force equals to mg cosine theta. And these guys here must work together to provide ma. And hence, mg sine theta minus the friction gives me ma. And with that, we can reach the final step, D, determine the unknown. So typically in an exam, you may have at most 2 unknowns in these equations, but you do have 2 equations, and hence you can usually solve for the unknowns simultaneously.